Assalamu alaikum. I am Imradul Haq Buyan. Today I will be presenting you empirical analysis of binary search and directed graph simulation with my teammate Alpha Bint Nahar Ariana and Shiabal Mahmoud Rafi. Let's start with question A2. We explore the efficiency of binary search. As many of you know, this algorithm works on divide and conquer principle, but it requires the data to be sorted first. Theoretically, it runs in logarithmic time or big O of log n. To test this empirically, we wrote a Python script that generates random integer array of increasing size ranging from 10,000 to 50,000 elements. Crucially, we ran 1,000 searches for every dataset size to average out any system noise and get a precise time measurement. Now my fellow teammate Shihab will continue.
Assalamualaikum, myself Shihab Al Mahmoud Rafi from CSE Department of East West University. Let's continue the project. Here represent our results. On the x-axis we have the array size n and on the y-axis the average time in milliseconds. As you can see, even as we quintupled the data size from 10,000 to 50,000, the search time increased by a negligible amount. We added a trend line which shows a very shallow curve. This visualizes the power of logarithmic scaling. Binary search is incredibly fast regardless of how much data you add. To conclude the first section, our empirical data successfully validates the theoretical complexity. Mathematically, jumping from 10,000 to 50,000 elements only adds about 2 extra comparison steps to the algorithm. This is why our graph was nearly flat. We can confirm that binary search is highly efficient for large data sets, assuming the initial cost of sorting is acceptable. That was my part. Now my team member Ariana will continue the rest.
Assalamu alaikum everyone, myself Alpha Bint Nahar. I will briefly explain our directed graph model and results. For this part, we used a directed graph model. Each node represents a user and a directed edge means one user follows another. We randomly created these edges to simulate social media behavior. We then calculated in degree and out degree and used BFS to analyze connectivity. Now, this graph shows the number of connected components versus the number of users. As the number of users increases, the number of connected components decreases. This means the network becomes more connected as it grows. Also, total in degree and out degree are equal for all cases. These results confirm an important graph theory rule and show a realistic network behavior. Larger networks naturally form a big connected group. In conclusion, our simulation proves that directed graphs maintain balance and become more connected as the network increases. Thank you everyone for listening.